Let's talk a little bit about nutrition. So I'm based at Turku College. I work with the Department of Primary Industries in New South Wales. And so for anyone that's not familiar with the place, just inland of Newcastle. And today I would like to share with you some of the results of the current project that I'm leading on supplementary feeding. So that's a project that's funded between AgriFutures and New South Wales DPI. And for the last few years, we've been experimenting with quite a few different ways of supplementary feeding and evaluating the impacts on honeybee colonies at the same time. So the whole reason behind it is really I'm very pleased, I should say first, that I'm hearing a lot more people talking about nutrition and getting excited about it in different ways to look after their hives, because it's actually amazing how, as an industry for bees, not only in Australia, I think in some ways we're actually a little bit ahead of other countries in terms of knowing the nutritional quality of some of our major pollen sources. But in terms of implementing it as a strategy into our businesses, especially with a changing environment, we now have varroa as well. There's still a lot of things, a lot of questions that we're asking about how can we nutritionally support our bees, either to maintain colonies, to build hives, or to get them through a dearth period, or to use it strategically to build hives for a specific purpose. So some of the questions that we were asking is not only how much should we be feeding, how often, but also what are actually the costs and benefits of feeding, because I think quite often we as beekeepers feel good about supplying something nutritionally to the bees, but at the end of the day we also want to know where does that actually get us, what impact does that have on the health of the bees, on the production, and how much better are our bees, and how much more honey or whatever service we are providing are we actually getting out of it at the end of the day. So the picture that we're looking at here is a picture of the apiary site. So this is an apiary that I re-established after having lost all the research hives at Turku College with the eradication of the varroa mite. And I took a little bit of a gamble of establishing a research apiary 2 hours north of the college again during the whole eradication process. But I have to say, luckily, I haven't lost the bees again. And so what we do every time we set up experiments is we try and set them up as equal and as similar as possible. So that's what you're looking at here. We we had 50 colonies. We equalized them as much as we could, around 10-11 frames of bees. We set them up with open-mated sister queens to try and keep the genetics somewhat similar, just to take out an extra variability. And we balanced them for brood and also food resources. And all of those hives have bottom boards that are also pollen traps. So they've got a little bit of ventilation, but yeah, they do have a drawer that we can pull out and trap pollen at any time. So I should mention that this research apiary actually was varroa-free until the end of last year. So the first time I found mites in that apiary was in end of October last year. And so that actually means that all of the studies that I have been doing on those hives at that apiary were actually without the effect of varroa. But in saying that, I will definitely go into what that means from a nutritional perspective if we did have varroa. So in terms of the kinds of treatments that we were looking at, we always try to keep some hives that we don't do anything to. So they are our control hives, and we can then test against those hives and how they are performing as to what difference our nutritional treatment is making. So we were interested in particularly manipulating the amount, or I should say what we are feeding, so whether they're getting sugar syrup or pollen at the same time, and also at what frequency. So essentially the 3-weekly and the weekly hives were getting the same quantities, the only difference being that the hives that we fed every 3 weeks, because not everyone might be able to get to the hives on a weekly basis, they just got that whole amount all at once. for the purpose of today, but feel free to come and talk to me anytime later on, and I'm happy to share whatever we've been seeing across other treatments as well. But today I'll be focusing on the control and the mostly fed hives on a weekly basis, just because I've got most data at this point to share with you on those hives. So to give you an idea of that site, so initially when I was establishing this research apiary, I was on a search for a poor site, just so that I could supplementary feed and actually measure what was happening there. So at that site, we did collect the pollen and we measured the protein content, but I can tell you that this particular site, it's a little bit of everything, but nothing much of anything. So they were getting a bit of a diversity throughout the months, but when we did the protein analysis, it was pretty much sitting above, like on 20%, sometimes below, sometimes a little bit higher. So it's really poor to average pollen conditions. It was only one spike in April where the bees were getting a bit of broadleaf tea tree, which we know is really high in protein, sitting around 35%. But at the same time, they weren't getting much of it. So that was kind of what we were working with in terms of the nutritional quality and quantity of the pollen in the background. So this is how we feed. We have been feeding inside of the hives because that's the way that we can control how much feed each hive is receiving. And so picture on the left, that is us feeding in between the brood boxes. So each of the hive has a full depth 8-frame brood box, and then they also have an ideal that is part of the brood nest as well. And we were feeding 300 grams of dry pollen on top of, it's kind of a thick paper or a thin cardboard, you can imagine it being, and we just simply fed dry pollen on top of that. We also gave the bees sugar syrup, so 2 liters of a 1-to-1 syrup every week. And then we go out and measure a whole bunch of things. So just to get an idea as much as we can about where they're sitting in terms of their health, their productivity. So we measure things like frames of bees, we measure the brood area, we do nosema every 2 weeks. We also look at the body protein, and that's something that I will talk more about in a few minutes. We look at stores, so we score the pollen, the honey, we weigh the hives, we trap the pollen, and we look at feed consumption. And so there's a lot of data that we're collecting and a lot of data that we're analyzing at the end of the day, but it really gives us an idea of what's happening in the background, like do they have high or low nosema at any point, or what else is going on while we are putting them under those treatments. So today I really want to focus more on the body composition and the protein, because the interesting thing is that, in fact, the body protein stores of honeybees really is correlated with their longevity. So I think it's something that often slips our mind in terms of thinking about it in this kind of way. But at the end of the day, a shorter-lived bee is able to produce much less in her lifetime than if you have long-lived healthy bees. So in our particular case, we were interested in the body protein of the emerging bees. So we collected bees that were literally just hatching, and then we thought, well, that's really only one part of the story, because what happens to those nurse bees that are actually looking after the developing brood? And we know that they can sacrifice their own body stores to be able to look after the next generation of bees. So we wanted to know what happens to those nurses while they're actually feeding the developing brood under poor conditions. And what does that potentially mean for their later life when they become foragers? I do call the nurse bees the heroes of the colony, just I think because they don't get way enough credit than they deserve, because they are the ones that take any kinds of pollen, whether it is low, high, good, bad quality, and they have to transform that into a jelly that they process using their head glands, using their fat bodies, and then turn it into a consistent jelly that they are feeding to the bees, to the developing larvae. So they are the ones that are really controlling what kind of nutrition they are feeding to the next generation, but it's all passing through them to be able to do that. So fat bodies, just quickly, they play a whole bunch of different roles for for bees, and often they've been compared to our human livers, so they play a role in nutrient storage and detoxification and immunity and water regulation and hormone regulation. And as you can see on the image there, on the right, you're looking at a nurse bee or also a winter bee. They need to have good body stores to be able to overwinter, especially in temperate climates. And for nurse bees, they need to be able to have those extra body stores, and it also is involved in their immunity and a whole bunch of other mechanisms, but they heavily rely on that. Whereas on the left side, you can see an image of what would be a forager bee. So once a nurse bee turns into a forager, it doesn't have that requirement to regulate nutrition anymore, and their fat bodies naturally shrink. Or the same is true if you have undernourished bees, and you would see fat bodies that are nearly not as developed. As I think, as we all have heard by now, is that varroa also happens to feed on the fat bodies. So I'll talk a little bit more about what that actually means. But the varroa mite feeds on both the pupae and the adults, and that impacts the bees in certain ways. But I'll touch on that again a little bit later. I just want you to keep that in mind. And generally, that's also why we see the mites feeding on pupae and adult bees at specific parts of the bee, because that's usually where they can access most of the nutrition in the easiest way possible. So that's why the mites are often or mostly tucked on the underside of, for example, adult bees. So let's talk about protein. And so I tried to simplify this as much as possible in a way to make it really easy to look at and to compare. So this was something done by Graham Kleinschmidt. He is was an Australian researcher in the 1960s and 70s, and he's found that correlation between bee longevity and body protein. And so his recommendation from looking at body protein in bees, for example, that are gone onto a honey flow, specifically when there's low pollen available, he saw a very quick drop in body protein and in terms of longevity of bees. And so after looking at different seasons and different effects on the bees, he said his recommendation was 40% protein is really what you need as a minimum, because after that you have a huge impact on longevity. And you can see that bees with 20 or 30% protein have much less of a lifespan of 20 to 26 days compared to bees that have up to 60-70% body protein. So I was very interested to see what happens under those feed treatments for those two different groups, controls versus fed bees every week. And to my surprise, and maybe later not surprise, in fact, the body protein of those emerging bees, there was no difference. So you might say, oh, is feeding really not having any impact here? But what is happening is, so what that tells me is that the bees are really investing all the energy that they can. So if they have conditions where they're still able to rear some brood, that they will still invest everything they can into the next generation, because that determines their survival going forward. So we definitely saw that the controls reared less brood, but in terms of their body protein, for the emerging bees at least, they still tried to put in everything they can for raising that next generation. So that is a pretty good outcome, really. But then when we looked at the nurse bees is when the story became a bit more interesting. So with the nurse bees, and these are averages across the months, so we were literally feeding the bees every week between March to June, and I'm just presenting the averages, but for the emerging bees, like the 60%, that was fairly consistent. There wasn't that much variability in the body protein. Now, looking at the nurse bees, the ones that are not fed, we're sitting on average around 40%. But I want to point out that particularly for the controls, there was more variation in the data generally across the months. And particularly in May, and this is why there's a little ghost bee at the 30% mark, there was a time when there wasn't much or less pollen available and quality, where the control bees actually dropped into the 30s in terms of their body stores. Whereas the hives that we did support with supplements they were comfortably sitting on 50% consistently throughout that period of time. So that tells me that we can actually measure the impacts of supplementary feeding by just looking at the body stores alone in those two different groups of bees. Now, they are not Christmas bees, but I just wanted to point out, or to remind myself to mention, that these are also the bees that are now going into winter. So if you're looking at longer-lived bees, then that's where that body protein in autumn becomes important. But at the end of June, we decided to stop feeding for a month and bring them through to winter and assess them again at the end of July. And at that point, like some of you might have decided to potentially take bees to almond pollination, for example. So we wanted to see what happens once we stop feeding. How do the bees respond? And so we did the same measurements again. And interestingly, like if you remember beforehand, the control bees were sitting at around 40%, the fed bees were sitting at 50%, but now, after we stopped feeding, that response actually disappeared, and also the fed hives are now sitting at 40%. So we are looking at a month later, and generally I think the important thing to keep in mind here is like once we start supplementary feeding bees, they very quickly respond to the supplements being available. But the response we only see 3 weeks later, because that's when the first generation of bees is hatching. So once we stop feeding, we see the result 3 weeks later, but it also tells me that once we do stop feeding, that response pretty quickly disappears again. So then looked at the frames of bees, and we definitely saw that the controls were slowly going downhill. I mean, this is also time of the year where bees would naturally decline in population. But to give you an idea of what we were looking at, so the control bees started off as 11 frames of bees in March, and by the end of July, without feeding, we were looking at an average of 6 frames of bees. So they had dropped in 5 frames of bees, whereas the ones that we've been feeding up until June, they dropped in 2 frames of bees. So we're comparing 6 to 9 in terms of, like for example, people taking bees to almonds, especially now that people are getting paid by frames of bees per hive. I think it's pretty obvious which ones you'll be taking to almonds. I just want to now touch on some of the effects of varroa feeding on bees that link into the story of nutrition and how it relates to varroa as well. So these are only some of the effects that I've listed here, but that go along with the nutrition story. And so some things that happen when varroa, for example, parasitizes or feeds on the pupae is that we know that those pupae can hatch with lower body weights. Now, lower body weights in bees translates into a smaller bee. So there's smaller bees that are hatching. That means smaller bees carry less resources as one effect. There's also research that has looked at the body content of those bees that are hatching from having been parasitized with varroa, and we know that they can hatch with lower body protein content. So that suggests that the protein synthesis and the growth the mechanism is somehow disrupted. So if you're already looking at bees that have less body protein because the nutrition is suboptimal, now we're adding varroa into the mix and they have even less available protein. I mean, I think that story becomes pretty obvious pretty quickly. Some other reports of studies were looking at the influence of food intake as adults when they have been parasitized. So this is only a very brief overview just to give you an idea of how varroa can affect bees nutritionally. And the other interesting thing, and I've read a paper about this on the plane coming here, and I thought I have to mention something about it, and that is that varroa also affects the transition of nurse bees to foragers. And I think this is a very interesting and a very crucial point, because it's something that, again, we don't often think about, where we were talking about those fat bodies, and naturally, those nurse bees would transition to become foragers. But there is a natural time frame where that happens, and it all comes down to how bees regulate hormones. It's a hormonal switch. It's correlated with juvenile hormone and vitellogenin and so on. But I won't go into detail of all of that. But the message being that if bees are being fed on by varroa, that transition from nurse bees to forager actually happens more quickly. So what does that mean for us? It means that the lifespan of those bees is shortened, because once they become foragers, that's what determines their lifespan. They essentially forage themselves to death. But if they have a shorter period of nurses and become foragers quickly, they will have a shortened lifespan. And at the end of the day, one thing that they did look at was, for example, pollen feeding, and whether that would allow the nurse bees that have been affected by varroa to live for longer, and they did find that that did make a difference. And funny enough, they said, oh, and the other positive side effect was that their immunity was improved. It's like, oh, is that really a side effect? I would say that's a significant finding, that they can also, it boosts their immunity, they can handle viruses and varroa much better. In this space, I think one thing that's still remarkable in some ways is, I'm talking here about pollen and feeding pollen, but there's still a whole other story about supplements and understanding how supplements actually work in supporting nutrition. And there's a very new study that has been looking at sterols, for example, and how that has helped to improve the 2 brood cycles that we've been saying, oh, that can support, protein supplements can support bees, but not really much longer than that. So I think in that space, there's still a lot more for us to really understand how we can use protein supplements more effectively, or what kind of nutritional components do we have to have in those supplements to be able to support bees. But that's a little bit of a different story in some ways. So yeah, in terms of just as a quick summary, so we saw that the colonies really invest all of their energy into the next generation, and it's the nurse bees that potentially suffer from using up their own body stores to support the next generation of bees. But if we do by increasing the bee longevity with supplements, we can end up with bigger bee populations, and especially, for example, in autumn or winter, when the bees are naturally shutting down, but we still want them to do a pollination job. And as I mentioned, so bees do respond very quickly to supplements, but the effect can also drop off very quickly. But of course, we're looking at that 3-week delay by the time the brood hatches as well. I did mention that well-fed bees can handle varroa much better. There's still a lot more opportunity to understand that in more depth in how we can support bees nutritionally, but we know that that is certainly an important part. And the other thing that I didn't get a chance to really talk today about it, but we have been measuring also the potential risk of sugar contamination to honey during all of those trials. And I actually found out that it is pretty hard to contaminate honey, especially if you're feeding small quantities frequently. So as long as the bees are taking it in a short time frame, and in some ways that is also the most stimulating. So yeah, when we fed small quantities very frequently, a few days apart, that was the most effective and the least risk of contaminating any honey, which we haven't been able to achieve. Not that that was the goal, by the way. But yeah, with that, I would like to say thank you to the whole team that stands behind this project, because it wouldn't be possible without them. And yeah, and thanks to all the financial support and funding bodies as well. And yeah, in future, you will hear me talking about costs and benefits. So that will be our next step, to look at what are the costs and benefits from an economics point of view. And yeah, thank you very much.